Here's how to write up your final practical in the microbiology unit. It's going to fill 7 to 10 A4 pages, including your results. You investigated the effects of different disinfectants on 3 different bacterial species. You can use this set of guidance notes as well if you did the investigation into mutual inhibition. You'll just need to adapt the notes that follow. Your report's going to have 7-headed sections. You're going to have an introduction, a proposed method. You're going to have a section on modifications to the method when you actually did the practical. Then your results. You're going to analyse your results in the following session. In the 6th section, you'll have an evaluation of the methods you used. And finally, you'll have an abstract. So let's look at those different sections in a little bit more detail. First of all, the introduction. You need to set the scene with some background on disinfectants. Watch the Moodle video and make some notes on their active ingredients and how they kill bacteria. Do they act on the membrane? Do they act on protein synthesis? And so on. Then look at your 3 bacterial species. You're familiar with them by now, and explain the aims of your investigation. From this, you can state in 1 sentence what you're going to test. That's your hypothesis. And the hypothesis, as I said, does need to be a single sentence. Finally, finish off with a sensible prediction based on the disinfectant and bacterial background. The next question is, how are you going to test your hypothesis and prediction? Well, start by thinking back to how you actually carried out the practical. Start by including a list of resources, and then produce a bullet-pointed list of the method using the present tense and using the 3rd person. Don't use I or we. Generally speaking, it's still recognised as good practice to use the 3rd person. So the bacteria were added to the plate, not I added bacteria to the plate. Don't forget that you need to talk about the variables involved in the investigation. The independent variable, for instance. The independent variable is the thing that you are manipulating. What is it you were changing? The dependent variable is what you were measuring. The next section is about what you actually did during the practical. Did you follow the procedure without any changes, or did you ensure maximum reliability by modifying it in some way? Did you encounter the unexpected? Did something odd happen? And how did you deal with it? For instance, you might have found that the agar took a lot longer to set than you'd expected. How did you deal with that? The next section is about the results and processing of data. So here you need to make sure you are thoroughly familiar with the guidance notes that you've got on the back of the assessment brief called Rules for Presenting Tables. You'll need 3 sets of tables. You'll need a titled table of your own raw data. Remember to give it a title. You'll need a separate table of the class's raw data. You'll be able to download that from Moodle. And then from that, you need to calculate the means of the whole class data. So what you'll need to do, for instance, is to calculate the mean results that everybody got for E. coli and, for instance, Dettol. And then E. coli and J's fluid. And then you repeat that with the other bacteria. Remember to use proper table format and don't put any units into the body of the table. The units should be in the headers. when you're calculating the mean values, do it sensibly. You can't claim a much higher value for the mean values than the original researchers were able to claim for the raw data. In most cases, the researchers calculated the raw data to whole numbers. Therefore, your mean values shouldn't go any further, at most, than 1 decimal place. Take a look at the raw data table for the whole group and see if there are any anomalies or outliers. These are things which don't fit the trend. So, for instance, if most of the group found that Dettol caused 25 millimeters of inhibition with one of the bacteria, but there's one set of data saying it was only 4 millimeters, then that's an anomaly. It doesn't match the rest of the data. You don't need to say anything more about it, but you need to identify it at this stage. And then you need to decide how you're going to present the data, the process data. How are you going to plot those means onto a graph? And when you plot your graph, remember the graph rules. They're all on the briefing sheet. In the briefing sheet, it mentions doing a statistics test. Don't worry too much about doing that. It's not required this year unless you feel that you really want to include it. But there's no extra credit being given for a stats test this year. Once you've processed your data, you're ready to actually talk about it. So now you get to the section called Discussion of Results, and you need to start by describing the overall trends. Then you need to suggest reasons for the anomalies. And then finally, but occupying probably most of this section, you need to use scientific background to explain what happened. Why did Micrococcus luteus experience greater sensitivity to, for instance, Jay's fluid? What is it about Jay's fluid that actually damages the structure of that particular bacterium? And this is where you should be able to link back to your introduction without bringing in any additional references. So think very carefully about that introduction. Once you've discussed the results, then you're ready to look at the evaluation of methods. And the evaluation of methods is the evaluation of what you did, not what you were provided with. So the evaluation isn't an opportunity to make excuses by saying, oh, the equipment didn't work, we didn't get the help we needed, and so on and so forth. It's how did you make the best of what you had? So, for instance, questions to answer are, what do you feel limited the precision of data and accuracy? And try and give a percentage figure, how much difference you think it made. 1%? 5%? 10%? How could you improve that accuracy and precision? Could you surmount those difficulties? And how much would they change that? Would they reduce the error from maybe 5% to 4%? Or would they completely eliminate it, which is unlikely? Once you've done your completed report, you're ready to do the abstract. The abstract is going to be the cherry on the cake. And in the abstract, you're going to have 4 paragraphs, and in total, your abstract won't occupy more than half a page. So paragraph 1 will summarize the aim of the investigation, again, in the third person. Paragraph 2, you'll summarize the procedure in the third person. Paragraph 3, what did you find? Just summarize the results. What were the overall results? And paragraph 4, summarize the evaluation. Any weak spots in the collection of data. The very last thing that you're going to include is a list of references and your bibliography. Remember to do it in Harvard format. Remember that throughout the piece of work, throughout the report, if you are drawing on other material, you should reference in the text. And remember too that your report is going to be checked for plagiarism using 2 different software programs. At the beginning, it's quite useful if you've got a contents list keyed in with the page numbers, and if you're proficient with Word, you'll be able to set that up at the beginning. Otherwise, you'll need to just do it by hand. So that's what's involved with writing up your 2017 practical.